Welcome to the podcast. Today we're talking about RESTful Web Services in ASP.NET MVC. My name is Richard Winslow. I work as an architect and team tech lead at Zinx Health, a company in Los Angeles that does cutting-edge healthcare IT as a web-based software service. So to start off with, you may not be certain that a RESTful web service is something that you're actually interested in dedicating time to, so let's talk about them right up front. As I'm sure you know, a web service is an interface, a programmatic interface that you provide to clients over the internet from your web servers based on HTTP. A RESTful web service in particular is one that bases its design, its architecture, on the architecture of HTTP, aka REST. Another popular way of designing these kinds of APIs is the remote procedure call style. You find this in SOAP and XML RPC, among other protocols. And while those approaches generally involve some middleware layers on top of HTTP that provide an object-oriented class-style interface, RESTful services instead make use only of the base abstractions of HTTP, which are narrower and less open-ended than a class-based system naturally is, but which nevertheless provide for the most common sorts of interface needs quite ably, and which have the additional benefit of enabling you to take advantage of the scaling benefits, scaling tools, and architecture of the web, and also don't involve the imposition of any heavyweight middleware, which generally means that there's less code required to come up with a RESTful service implementation or to consume a RESTful service on the client end. There, the simplicity benefit is especially noteworthy. So REST and RPC are different. RPC is like OOP, but REST has benefits once you learn it. Its architecture scales well. Since servers are stateless, for example, you can throw hardware at the problem at the back end. And since the actual interfaces, the operations between client and server have a uniform interface with certain guarantees, this enables you to also take advantage of infrastructure in the web that makes things faster or more secure or other benefits. So if you're up in the air about web services and about REST in particular, RESTful web services in particular, one big reason to be interested is because of Web 2.0 style applications. And here I'm specifically talking about the desktop style user interfaces, very dynamic web apps, you know the kind, where a client application, generally written in JavaScript, hosted in the browser, is doing all sorts of things under the covers against the web server infrastructure to get information, present it, give the user choices, have them interact directly and gracefully with data rather than spreading those interactions out over a clunkier and more time-consuming traversal of web pages. RESTful style services are perfect for this kind of application. They are, as I say, very simple to implement on the client end and simple on the server side as well. And this is because, as I'm sure you're getting tired of hearing, REST is the architecture of the web as defined by its principal architect, Roy Fielding. I mean, HTTP 1.1 rather than the web generally, of course, in which there were many more players. If you Google Fielding dissertation, you'll find his much more erudite explanation, of course, in depth of the architecture. But again, as I'm sure you're getting tired of hearing, the architecture has benefits. It's designed for scaling, for anarchic scaling, meaning that scaling isn't just achieved through centralized provision of resources, but through investment and innovation all over the web. Even if you're not building one of these kinds of apps, perhaps others are and they're interested in your data, your services, And so the easiest way for them to consume them is if you provide them in the form of RESTful Web Services. And of course, you may find yourself on the other end of that sort of relationship, although this talk may be of less use to you for that since we're concentrating mainly on the back end. But it's useful at least to know about the general design. So enough about REST. What about REST? Well, to understand REST, the best approach is to consider its most popular example, that being HTTP itself. The fundamentals of HTTP, of course, are request and response. Web client, a browser, for example, will typically request a number of resources from a web server or server farm. It doesn't actually know what machine it's talking to. In this case, our hungry browser wants its web page, and since there's a link to a picture that appears on the page in the HTML, of course it requests the picture as well. The web server has all sorts of resources on it, different representations such as HTML, JPEG, XML, PNG, who knows what, .js, many of them static, some of them dynamic. But in each case, the fundamentals of request and response are the same. Looking here in slightly more detail at what a request and a response look like, an HTTP request consists of a method, a URL, and some headers. In this case, the method is get. Here's a URL. Here are some headers. Obviously, in the real world, you get more headers. It's a little more complicated, but one gets the idea. And if you type this URL into the address bar in your browser, the browser is going to issue a GET like this on your behalf. The response contains a response code, a number, and these numbers are described in the HTTP 1.1 RFC. 200 means OK. This is the one you're hoping for in general, of course. And the response also has headers. Additionally, the request and the response both can have a body. Typically, a GET does not have a body, but other methods such as POST do. And of course, bodies in the response are quite typical, as you're generally wanting to get something from the server to the client when you are issuing a request and expecting to see it in the body of the response. Sort of fading out to the architectural characteristics of these minutiae. Resources, for one thing, have identities. And when we're talking about resources, as I illustrated earlier, we're talking about things like web pages, pictures, that sort of thing on the web. But in your RESTful web service design, as we'll see later, resources can encompass any kind of abstraction, any entities from your domain model, for example, etc. But one thing that is true of all resources on the web is that each has a unique, globally unique identifier, the URI, or URL, if you will. In this case, of course, you know the pieces of the URL, the domain, the path, and we'll see later why this URL looks like it does in my example. Another thing resources have is a representation. In this case, the client is requesting an HTML representation for the resource that it wants, and the server willingly supplies it. And this information happens to travel also in the headers, although, as again we'll later see, there are other ways of approaching specifying the resources that you want, or the representations rather. Resources, we say, in REST have a uniform interface. In HTTP, this is expressed as, for one thing, the set of methods and their semantics. The GET and POST methods we are all familiar with as those underlying hyperlinks and web forms. But there's a somewhat wider set of methods specified for HTTP. This is what we call the uniform interface from the REST architectural perspective. They're a small set of operations, verbs if you will, that are supported by the web infrastructure on resources. You can get a resource, you can post a new resource, you can put a new representation in a resource, you can delete a resource. Only the get and post methods are directly supported by the browser through HTML, like anchor tags, hyperlinks, allowing you to invoke a GET from your HTML content when the user clicks on the hyperlink. This, of course, invokes a GET in which this relative path is added to the base path to form a URL, and the resource is gotten and loaded in the browser. Post is enabled in HTML through HTML forms. Of course, if you have a method post attribute for the form, then that's the HTTP method, that's going to be executed against the path specified in the action. The other verbs, put, delete, and there are others options, but these are kind of the important ones, you have to access in JavaScript. All of the major browsers support the XML HTTP request object, which you may or may not know is actually a W3C standard, but it is common to use a JavaScript framework like jQuery in this example to both simplify your use of this interface and also to abstract you away from differences and incompatibilities between browsers in their implementation of this critical feature. Here we're using jQuery to make an AJAX call. Of course, you're familiar with the term AJAX. If we're talking Web 2.0, we're talking AJAX. And this code is making a request against a backend with the put verb, or rather I should say put method, and the data that's going to go into the body of the put request is in this new email object. We'll see how this kind of thing actually goes as we go along here. Part of the uniform interface is also the results, or I guess in HTTP we call them status codes. Having, again, a narrow, well-defined set of status codes with known semantics enables a general-purpose tool like a browser to do the right thing when various responses and various conditions come back, and also for the web infrastructure, caching servers, and the like to also know what to do with a response from up the line. Some typical status codes include 200, okay. As you know, 201 is what you're supposed to get back from a post when it creates a new resource successfully. 400 is the web equivalent of invalid argument. Perhaps one of your URL parameters is incorrectly formatted or something a bit more abstract. 404, well, we all know about 404. Another important architectural characteristic of the web and of HTTP is that it is layered. Because the uniform interface isolates client from server, the client doesn't know really whether it's talking directly to a actual web server containing the resources that it's interested in, or whether there is an intermediary. And of course, on the real web, there are all sorts of intermediaries. There are caching servers, proxies, there are load balancers, gateways, all sorts of things. And the uniform interface helps these infrastructure elements know the right thing to do for all cases, because the semantics of the operations are known as well as the responses. In this example here, of course, we illustrate the interface of a caching proxy, a content delivery network, for example, to reduce the amount of load on your web servers because it's able to cache resources that are not out of date and provide them to clients without having to consult the actual backend. A more abstract but still important architectural characteristic of HTTP, actually of REST per se rather than HTTP, this is almost illustrated concretely more in HTML itself than in the protocol, but it's important nevertheless that the web is essentially a giant state transition diagram in which the states are hypermedia documents containing links that are the transitions to other states. This is why in REST this feature is called the hypermedia constraint. The idea is that a hypermedia resource contains all of the information necessary to embody the state of the user's interaction with the back end. so that everything the user can do next is embodied in the hypermedia of the resource that the client now owns. The server, since it doesn't have to maintain any of this, it doesn't have to know what state the user is in so as to know what's legal next or what to expect. It doesn't therefore have to maintain any state. It is stateless and therefore much more scalable. And here we see how that boils down in practical terms to the server temporarily doing work to take a request issued from one hypermedia resource, do the work at the back end necessary to fulfill the request, and then giving back a response that again embodies a new state. Here we're starting off on the main page of a blog, and the blog allows you to register as a user, maybe to post comments. And part of the state embodied in that hypermedia is what blog you're on, so that when you register as a user, it will know, the back end will know what blog you are interested in being a user of. Here the user is following a register new user link from the main page, which will now, in the new page that is returned as a response from the server, contain this form that's got that information in it. When they submit that form, the server, thanks to the fields that were in, including a hidden field that was in the form, has the information necessary to place the new user in the database behind the web servers, and then provide a new page which has a link back to the main blog, but also tells the user that their registration is completed successfully. And as we've already said, when you're stateless on the back end, you scale up more easily. This is kind of a concrete example where a bunch of clients talk to a load balancer which is able to distribute the request from the clients at random or using whatever algorithm it likes to a whole set of servers in a web farm. It doesn't matter which it picks because there doesn't need to be any state in memory on those web servers representing what each client individually is doing. So to recap briefly, in REST, clients act upon resources. Those resources could be anything in a general abstraction domain, as long as there's something that has a representation or a set of representations and that they are identifiable globally through the URI. The hypermedia constraint, as we've just discussed, constrains a truly RESTful web interface to place all of its state on the client and free the server of the need to maintain client application state. And this generally takes the form of documents with links, hypermedia in other words. But as we'll see in a typical RESTful web service interface, especially one that you build for yourself for your own web applications to consume, and especially in an AJAX Web 2.0 type of situation, the need to constrain your client software to only follow links that are explicitly provided in representations is not a strict requirement as long as your servers remain stateless and your interface remain uniform. In fact, you can look soon on my blog for a fascinating article, or series of articles, I think, about how RESTful web services in general don't need to follow the hypermedia constraint religiously. But they do need to be stateless, and as we've discussed, blah, blah, blah. Layering is an explicit architectural characteristic of REST. Everything that you do, as well as the design of the protocol itself, has to allow for the seamless introduction of intermediaries and other infrastructure to solve problems like scaling and security. And of course, the uniform interface decouples components, and with its explicit semantics allows us to make assumptions at every layer in the interaction. In particular, there are well-known semantics for the methods, for the verbs in the uniform interface, The get operation is defined to be safe, meaning that it doesn't have any side effects on the back end. The idempotent operations, put and delete, guarantee that you can perform them multiple times without the end result, the side effect, changing. In other words, they have side effects, but if you accidentally send two of them that are exactly the same, if you put twice with the same representation, then it doesn't matter. You will have had the same end result no matter how many times you call it. And of course, in a networked, scaled, layered system like this, that's critical. To illustrate one case, if you try a put and then never hear a response back, it means you can try it again. And as we discussed earlier, responses are an important part of the uniform interface as well. And an example of that importance is the cacheability or cacheable characteristics and headers of HTTP responses that enable infrastructure to decide whether to cache resources. So in case you're shopping for web service interfaces, let's briefly cover the REST versus SOAP debate. First of all, REST is simpler, I think, to write code for, since the uniform interface itself is simple. At a bare minimum, getting a resource from a web server is just a get with a URL. Creating a new one, a post, is again really just a URL and some text in the body containing property names and values. And put and delete and the other methods are actually similarly simple. The illustration here is a JSON representation of a travel itinerary. And I show it here to contrast it with the next slide, on which we see what is actually the first example in the SOAP standards primer, which is the same itinerary along with a little bit of additional information in an XML SOAP envelope. JSON, of course, being a representation that you'll typically consume as a Web 2.0 AJAX client of a RESTful web service interface. And a thing that you lose with SOAP is the scaling benefits and other security or other benefits of the layered architecture of the web, because you're basically tunneling through the web using POST. POST being the HTTP method that has the most open-ended semantics, and in other words, having really no guarantees as to its side effects. REST is certainly more lightweight on the client side, where you're able to get off and running with just a bit of JavaScript code. And JavaScript frameworks, which are usually, or at least some of them are free, make it easy to be browser independent and to write very little code to do a lot. And in fact, scripting languages on the server side, particularly, for example, Ruby on Rails, make implementation of RESTful interfaces similarly lightweight and straightforward on the server side, and cheap for that matter. On the other hand, there are certainly arguments in favor of SOAP as well, one of them being that because REST is different and unfamiliar to many, it's easy to get wrong. There is, for example, the famous case of Google Web Accelerator, which was designed to speed up your web browsing by eagerly requesting website content that was linked to from the pages you were browsing. But there was a service that had designed its interface in such a way that hyperlinks, which are just gotten with GET, had a side effect. In this case, actually, in a view of photographs on a site, you could hit a hyperlink and the site would delete a photo. Now, of course, in the RESTful architecture, a GET is not supposed to have a side effect, least of all a destructive one, like deleting something. But once your server-side logic is in charge after receiving the GET request, it can do what it pleases. And these folks, being ignorant of the constraints of the architecture, went ahead and made the GET method in this case have a very destructive side effect. Fortunately, there was a workaround. These kinds of gets, any get that would have that kind of side effect generally has to identify, not just identify a resource, but things to do with that resource or other parametric information. So Google basically modified web accelerator so that if the get has URL parameters, it doesn't follow it automatically. But such an unfortunate kludge and other problems that can arise in other uses of web interfaces may result from people's incorrect use of REST, and in particular their lack of observation of the semantics of the uniform interface. Also, SOAP, being an enterprise solution, has built up a big tool suite, and although REST, especially in the open source arena, is catching up, if you are looking, however, for certain kinds of enterprise solutions from certain vendors for security, reliable messaging, etc., there's a lot of that kind of thing built up around SOAP. SOAPy build-up, if you will. And finally, although I put the bullet points in the wrong order, finally, and this is perhaps a subtler point, but important one to programmers often, the semantics of SOAP, with its type safety and formal contracts, differ significantly from those of REST, and it's, I think, accurate to make the analogy between static versus dynamic programming languages. So if you like an interface in which the metadata describing the contractor is an actual explicit artifact of the interface, and hence you have a more type-based and type-safe kind of model, then SOAP is for you. But as this chart that I totally stole from Mr. Andrew Stevens' blog illustrates, back in 2010 it did anyway, the simplicity of REST is tending to win out in web interface implementation circles. So if you're still here, you're probably interested in how one goes about actually designing a RESTful web service interface. And the fundamentals basically involve identifying what your resources are, and these may very well come straight out of your domain layer. Here I'm illustrating the blogging domain layer, in which blog owns many posts, each post owns many comments, etc. You have to come up with a strategy for mapping URLs to your resources so that each resource is uniquely identified by a URL. Here, in a domain in which you have multiple blogs, say a blogging hub site, for example, your URL for getting at a particular post belonging to a particular blog might look something like this. You also have to plan out the set of operations that you're going to support on your resources out of the uniform interface, and the representations that you expect your clients to consume your resources in, which may differ depending on how you picture your clients interacting with your service, whether they're going to be using JavaScript, whether you're going to want to be able to do things in the browser with scripting turned off, whether you're moving into a situation where XML is already a force and XML on the client side is already being processed, or on the server side perhaps, and you want to be harmonious with this. However, it is common for JSON and JavaScript-driven AJAX applications to be a very popular representational format. So now, as we get to the particulars of RESTful web service interface design, and particularly URL design, routing design, we are going to be talking largely about conventions that were established in the Rails framework for Ruby, in large part because at Zinx we adopted a RESTful routing library that itself implements those same conventions. And as I say, this aspect is largely concerned with URLs and how they are routed to resources. In Rails, a set of resources is represented by a base URI, or a URL if you will, where you're adding identity information onto the URL, onto the path of the URL to identify individual resources, but a whole set of related resources have this base URI, which, if you get it, lists the resources. So a get operation on the base URI representing a bunch of resources or a set of resources lists them all. And that means that what you get back in the response, the representation, is some kind of list. And you decide, of course, as the implementer of the code behind the framework, what that list looks like, what representational formats you support. Post adds a new resource to the set represented by that base URI. And there are some rare interpretations of delete and put, but for sets of resources represented by a base URI, it's really get and post we're talking about. If you then talk about a URI that has ID information on it, in other words, that represents an individual resource, a get retrieves a representation of that resource, of course. A delete destroys it, as you might imagine, and a put replaces it, or can create one if it doesn't already exist, although I have an asterisk here because, as you'll see in a coming slide, the Rails conventions don't actually allow you to create new resources in this way because the conventions involve numerical IDs that correspond to database keys at the back end. So here's an example of a base URI representing a set of resources. My domain where I offer blogging hub, and here are the set of blogs. When you qualify that with an ID, it represents an individual resource. So this URI represents the set of resources, and if you were to get it, you would get a list of the blogs in whatever representation you ask for it in and that I offer it in. And this, of course, gets you a representation of the individual blog identified with the ID 789. An important feature of the Rails conventions is that these representations of resources are hierarchical. In other words, resources as identified with base URIs can represent other resources that are identified by a further qualified base. For example, myblogs.com/blogs represents all of the blogs. If you get it, you list all the blogs. But blogs/29/posts represents all of the posts for blog number 29, and so a get will list them. Again, this is a base URI representing a set of resources, but in this case it's hierarchical. It is itself a set of resources belonging to a particular resource of the blog type, which is further up the hierarchy. Finally, if we go deep, we get all the way down to comments. We can post a comment by posting to the comments base URI. This is a URI, another level of hierarchy down, representing the set of comments for a particular post. In this case, it is post number 137 from blog number 29, and posting to that URI would add a new one. As I discussed in the previous slide, posting adds a new resource to the set. And in the Rails framework, and as we'll see, the RESTful routing library allows us to do the same in the MVC framework. The resources identified by various pieces of the URL are mapped by the framework, and the routing library in our case, to controllers. The blogs controller handles requests against the set of blogs. The posts controller handles requests against sets of posts. Of course, there is one set of blogs, but there are multiple set of posts because each blog has a set of posts belonging specifically to it, and similarly down the chain we have the comments controller. And of course, if you've done ASP.NET MVC work previously, then the way that these URL segments relate to controllers looks very familiar. We almost don't need something like a RESTful routing library to help us with the routing, but in a complex interface with lots of sets of resources, and believe me, it isn't hard to get there, the hierarchical nature of it becomes tiresome to represent piece by piece in the regular manner of representing routes in MVC, and so a library helps you with building up that hierarchy more eloquently. As I mentioned earlier, there are limitations. There's really a set of limitations associated with the fact that this ID convention involves numerical IDs. Rails and other frameworks like Active Record that it interacts with basically make for very small code, very simple, very few statements that is able to do a lot of things, but it does that by imposing a lot of conventions that guide how the framework distributes work. And in this case, the fact that IDs are numbers simplifies the relating to database records case, which is by far the most common. But because of it, also, for one thing, you can't have nice human-readable resource identifiers in the URL in case that's something like that you wanted. For example, on a blog or a journalistic site, the story or the post might be expressed in the URL as a canonicalized representation of the story title, and that's a very common convention actually, but using the Rails conventions, that's hard to do. You have to work around the routing, and that's not comfortable. And also, as I was pointing out with the asterisk earlier, it makes it impossible to use put to create new resources. The reason is that since the URI corresponds to the identity of the resource and it includes a numerical identity specifically for this new resource that you are creating, you would have to, on the client side, predict what the ID, which is generally going to be a key that the database engine wants to generate itself, is going to be. So when you want to create new resources, really, if it's all Rails conventions, then you have to only use post. Amazon S3 is an example of a very successful web service, RESTful Web Service interface in which put is used to create resources. In the S3 case, you can give any arbitrary name to a bucket that you're creating, to a storage bucket that you're creating, and if you happen to use a name that's already used on your account, then it just overwrites the previous representation. But if it's numerical IDs and they really correspond to database keys, then that's tougher. Finally, when you really need to do some kind of RPC style operation in a RESTful web interface, of course HTTP itself provides the very backdoor through which SOAP tunnels to do all of its work, which is post, the so-called overloaded post. In other words, while the first description of how post is supposed to work in the RFC for HTTP 1.1 describes how it's essentially designed to create subsidiary resources. So this is the post as create kind of case. Another legal interpretation of it is to quote-unquote provide a block of data such as the result of submitting a form to a data handling process. And in this case they're saying, well, maybe you're not actually creating a resource, maybe you're just doing something else, a data handling process. Hence, there are no safety semantics to post. It's perfectly legal for there to be any sort of side effects to its execution on the server. It's neither safe nor idempotent. And so the web infrastructure doesn't try to cache its responses or anything like that, which is, of course, why RPC over HTTP protocols use it. It can make sense for there to be multiple representation formats for a given resource in your service interface. For example, blogs number 42 might have an HTML representation, which is the way that you actually load it as a page in the server, whereas there might be other pure data kinds of representations like JSON or XML that might be used for more automated purposes in script. As I've mentioned previously, though, JSON is very common for JavaScript-driven applications on the client side to want to consume. And like any programming application development task, or interface development in this case, you have NFRs, security, for example, a non-functional requirement. If you have privacy concerns surrounding the information that's going back and forth to your service interface, you might consider SSL as a means of obfuscating that information. That's as easy as putting HTTPS in front of the URLs that you are using in your RESTful service calls, and of course configuring your web server to support SSL. And of course, if you're authenticating your users, there's kind of a variety of solutions, build or buy kind of decisions to make, and ASP.NET and IIS do offer a number of ways of supporting Windows authentication, Active Directory kind of authentication, or domain authentication through HTTP. Since it's part of the uniform interface, part of your design is going to involve decisions about what status codes you're going to provide. In certain cases, of course, the usual 200, that's great when you're successful, and 500, I guess, is okay when you throw an exception and crap out. But there are others worth considering. If you are using post to create resources, then returning a 201 is nice. Tells the web infrastructure that a URL got created, and in fact, if you include a location response header along with your 201, then the web infrastructure knows what the URL is of that new resource, and generally you are returning the actual representation of the new resource in the body, so that enables caching. Bad request of 400 is going to be a very common kind of a response for you to provide, indicating that your input to the request was somehow incorrect or malformed or improper. 401 is the gateway to authentication by telling the client that they were unauthorized to access a resource, and in conjunction with certain headers enable you to use HTTP authentication methods to facilitate authentication through the browser. 403 is interesting as a counterpoint to 400. Bad request, 400 is, as I say, invalid arguments, but a 403 specifically means that the request is actually formed correctly, but the server refuses to carry it out. Maybe it's something that you can't do at this time of day, or some factor like that. A 403 is just the right thing for that kind of situation. 404 you know about, but in a web service interface, there are all sorts of things that might be not found, not because they are a static resource that isn't in the place you expect it to be on the disk in the web server's file hierarchy, but rather, for example, instead a domain entity whose identity doesn't exist in the database anymore, or never did. And a 409, a conflict, is a nice status code to return, for example, when the client tries to create a new resource with the same identity as an existing one, and that doesn't necessarily mean the identity in the URL in the route, but maybe there's other identifying information like an email address that's actually used as the back end as a unique identifier for users. And if you try to register a new user with somebody else's email address that already exists, then a 409 would be an appropriate response. And here are some additional design factors you could consider. For example, how you offer multiple representations for the same resource. In the request, there is an optional accept header in which you can state what resources based on MIME types that you're expecting, what representations rather you want or will accept. But because a lot of frameworks or early frameworks didn't allow you to set this header, and also because this is easier when you start passing your URIs around, a lot of service interfaces instead make the representation where multiple representations are possible, makes it a feature of the routing, a feature of the identifier, as illustrated here, where we get our posts in JSON form or in XML form based on what URL we use. conditional get is a way of reducing the load on your server and increasing response time to your clients by telling the client that it can use the representation that it already got earlier and cached, because that representation hasn't changed since the last time they got it. Implementing conditional get involves just a couple of headers in the request and the response, but the design necessary to support it faithfully can actually be tricky in some cases, in a lot of cases, because for things that are dynamically generated out of database state, for example, you have to have a notion of how that database state has changed in a way that invalidates earlier representations that you've given back. You can't, in other words, just give a particular time for expiration. If something happens that changes the data that drive the representation, then you've got to tell the client that they need a new one, even if it only happened a second ago and they just got it 3 seconds ago. So sometimes maintaining dirty information, maintaining server-side caches that tell you what's up to date, or hashing information in the database or in other resources on the server side might be useful ways of implementing conditional get. Surface versioning is often a good idea, and this one's pretty easy. You just introduce version information into the base of your hierarchy of URLs that you use in your service interface, like this. And then there's the hypertext constraint. Now, it's a fact that in the web itself, and also in RESTful web service interfaces that are consumed by a lot of clients, or consumed by clients other than the designers themselves in their own applications, a real application of the hypertext constraint or hypermedia constraint really does serve to abstract the clients from the service implementation. If everything that the client can do takes the form of explicit links in the representations that the service gives back, then the service, for example, is free to rearrange its routing. It can change its representation of URLs, change the hierarchy, add layers, switch things around, whatever. And as long as the client knows what to do with particular kinds of links in the representations that you return, then the client is insulated from these kinds of refactorings. And there are micro formats or XML-based formats, HTML-based micro formats that actually attempt to provide this kind of abstraction of representation. But unlike the web, in which human beings are actually making all the decisions about state transitions by clicking on links and the like, in an AJAX-driven application, in a Web 2.0 application, there's script code doing a bunch of stuff under the covers, and a lot of what it decides to do automatically on the user's behalf is based on its assumptions about how the service operates, even if what it does in terms of forming URLs to get at resources is based on hyperlinks in the hypermedia resources that it receives. Your service can still refactor itself in such a way that what the client-side software wants to do doesn't make sense anymore, if you catch my drift. And for this and other reasons, which I will discuss in my blog post, as I mentioned, it is often not worthwhile for you to try to pursue this hypermedia constraint slavishly, which is kind of, and I'll mention later that there's a great RESTful Web Services book from O'Reilly that you ought to read, but it's very heavily in favor of following the hypermedia constraint religiously, and this can have downsides and very nebulous upsides, especially, as I say, if you are the consumer of your own RESTful interface. Okay, so getting finally to the meat of the matter, I don't actually want to go into much detail here in the slide deck, as I've already gone into great detail on other subjects, about ASP.NET MVC itself and the implementation features that we'll be using in the demo, because I can go into that in the demo. If you were here, you're probably already an MVC aficionado, or at least an educated neophyte. So you know that MVC, unlike ASP.NET Traditional or Classic, maps URLs to controller classes rather than to ASPX pages. The controllers have action methods that are the methods actually invoked by the framework, and these action methods return a view. In the regular web page generating case, that view would be typically a razor-based view, razor being the new MVC page generation template language. And to complete the triad, to put the M in MVC, the MVC framework also formalizes the notion of the model, that being a type or complex type that is shared between the controller and the view. So the controller has the task of setting up the model, for example, getting information out of the database to fill a model object, and then passing it along to the view, which uses the contents of the model to render itself. MVC routes look like this. Really, there's not much use for me to go into great detail here, as the MVC documentation describes the routing in quite good enough detail itself, and we'll be using RESTful routes, which are somewhat different, although similar in important ways. Speaking of which, we will be using Steve Hodgkiss's RESTful routing library to do our routing instead of the regular MVC routing. And here's a link to his site for it on GitHub. The package is also conveniently available through NuGet, the open source .NET package manager that integrates with Visual Studio, and I will be using it that way in the demo. And beyond that, it's often useful to have some kind of framework on the JavaScript side, abstracting you away from the AJAX functionality embedded in the browser. As I mentioned previously, both of these things are actually optional. You can bootstrap a RESTful interface and its clients without them, but I will be using them in my demo. So the RESTful routing library uses a Fluent DSL, domain-specific language, built out of lambdas in C# to express the routing hierarchy. And this is very similar to other Fluent DSL-like embedded languages in C# like Fluent and Hibernate. This sort of thing is all the rage in the C# community. So what's happening here, and once again we're illustrating the blogs domain, which actually is different from the domain I'll be doing the demo with. Here we have a declaration of a set of resources that are handled by a controller called the blogs controller. And within that set of resources, for one thing, we are making an alias so that in the actual URL you could use /weblogs rather than /blogs. Without this alias, which is an unusual feature actually, you'll often just use the name of the controller. The framework is actually going and looking at that controller name, and in a very typical use of the combination of convention and reflection in .NET, it is using that type name, slicing off the controller part, and then taking the rest of the name to be the URL snippet that will map to that controller. In other words, since this is a top-level set of resources, we're not inside of any other declaration, our domain /blogs would map to this controller, to the blogs controller. In other words, if we use our domain /blogs as the URL for some RESTful call for a get or a post or whatever, then it's this controller and its action methods that would end up handling those requests. But here we've given it an alias so that it's weblogs instead. But imagine that weren't there, it would just use this part of the name of the controller. Again, combining convention and reflection. So inside the lambda that we are feeding to this resources declaration as an argument is all the stuff we need to know about this set of resources. Its alias, what operations are supported on it, and in Rails, and I don't know the reason for this actually, maybe there were name clashes between HTTP methods and Ruby or Rails stuff, but in the Rails set of conventions, the actual action methods on controllers are not the same as the HTTP method names. For example, a get on a set of resources actually ends up going to an action method called index, whereas a get on an individual resource that is identified by a numerical identifier, as you may recall, invokes the show method. And actually, I guess the fact that those are both gets but do different things illustrates the reason why they needed to have separate names, now that I think of it. Duh. So here we're saying, by use of the only function here inside this lambda, we are declaring that only these operations are supported by this controller. In other words, only these operations are supported on this set of resources. Within this set of resources, further down the hierarchy, declared here is the set of posts. Within each blog, there is a set of posts. You see how this relates to the URL examples that we were talking about earlier in RESTful Web Interface Design. So, for each post, or for the set of posts, I should say, the operations that are supported are all the operations except these. So you see, you can do it by inclusion or by exclusion, declare the operations supported by a resource or set of resources. And in this case, what we are declaring here is actually equivalent to the one above. Here we're saying you cannot create a post, which is to say you can't post one in the HTTP post sense, not the blog post sense. You cannot update one, in other words, you can't put, and you can't delete one, in other words, you can't destroy. And these are all, again, what the names of the methods on the action methods on the controller class would be if these operations were supported. So, because you do not support post or delete or put, then all that's really left is get, which is what's allowed here. So these are actually kind of equivalent. Finally, another level of hierarchy down, we have the comments. There's a set of comments supported by the comments controller for each post. And you get the idea. Here we're saying you can do anything except destroy them. But the actual declarations here, as far as what you would want to do with a blogging site, are nonsensical, but they illustrate the concepts nevertheless. So if you had, from that previous declaration there, a blogs set of resources, and within that a posts set of resources, as kind of in a simplified way declared here using the RESTful routing syntax, here are some kinds of things that you could do. If you do a get against the URL blogs, and we're just assuming the domain part to the left of the path here, then the controller that is invoked would be the blogs controller, and the action method on it that would be called would be index. If you post it against the blogs path, in other words, if you're looking to create a new blog, then you would call, what do you know, the create method on the blogs controller. Get of a blog with an ID, in other words, as you remember here, now we are identifying an individual resource because we're providing an ID, then you will invoke the show action method on the controller, and that show method will get that ID as a parameter. Same thing for put, as you can imagine, except now it's the action method is update, and same thing for delete, except the action method is destroy. Going a level of hierarchy down, if we do a get against a URL that is of this form, where there's some specific blog ID here in the path between blogs and posts, then we're going to hit the posts controller and we're going to hit its index action method, and that method is going to get the blog ID as an argument. Because now, there's the posts controller, it's an instance that is generated by the framework to handle this request. It doesn't have a blog representation, a blog's controller or a blog domain object or whatever already made for it to represent the blog that it belongs to. So the controller, the index method on this controller, or any method that we call on this controller, because it's a subsidiary resource, needs to have the identity information to be able to tell what blog this set of posts belongs to, so that it can then carry on with that in its database operations to get the information that it needs. So a get on the URL of this form calls the index action method on the post controller and passes the blog ID. A post, designed, of course, to create a new post in the posts, way overloaded use of the word post here, calls the create action method and passes a blog ID. A get of a specific post invokes the show action method on the post controller, passing two parameters, the blog ID and the ID of the post. As we'll see later, the names of these parameters on these action methods are actually important. The show method needs to have an integer type blog ID argument and an integer type ID argument. And if you were to call these anything else, it, in its use of conventions and reflection, would trip up. It would be looking for a blog ID because it knows that these things are called blogs. It knows that because it looks at this name, the blogs controller, cuts off the controller part and figures, okay, the name of this set of resources is blogs. It actually, in the library, does analysis of the word to turn it from a plural to a singular, and there's a very popularly reused piece of .NET code that if you look at the source for the RESTful routing library on GitHub, you'll see that they took a copy of it that does that kind of morphological conversion on words. And so it knows that the ID, the kind of ID that would be passed in for a blog would be a blog ID, and that's the name that it will look for. And if you name it something else, then you'll get very bizarre errors that don't tell you right off the top that this is the problem. Believe me, I have run into it. So remember, these names need to correspond. They need to be of a form that the routing machinery and the library can find. And of course, a put, again, same URL, we're calling update and we're passing it a blog ID and an ID, and delete, same deal, but the name of the action method is destroy. Finally, the demo. So here we are in Visual Studio 2010, and we want to create a RESTful web service. The kind of project I'm going to create to do that is an ASP.NET MVC3 web application. I'll just call it RESTful Demo. And we want to create an empty application for this. The other templates offer built-in authentication strategies, and we're not going to bother with that for the purpose of this demo. Looking at the project, there are some basic templates here in the views folder that undergird all of the views that you produce. Just some basic stuff like including the style sheet and the jQuery JavaScript sources. And also noteworthy here is the style sheet, which actually I'm going to just quickly add a couple of items to. This isn't a CSS webinar, but there's some stuff that I'll at least want to be clear on the screen, so I'm just going to add some stuff, putting borders on tables and some vertical space between things. So the domain I've chosen for the demo is personal finance, even though I use the classic blogging portal example throughout the slide deck. And I have already pre-built a little personal finance repository fake project. It just offers a database-like interface over domain objects that are in fact just stored in memory. There's not even any persistent storage. And I'm going to be using its services in the personal finance repository namespace later on. But first, there's another package that I need to include, that being the RESTful routing library, the Steve Hodgkiss project that I mentioned previously. To do this, I am going to use a tool called NuGet, which if you don't have it, you should get it. If you have it installed, it's an open source project, a package manager for .NET open source packages. There's an online library of numerous packages, .NET software that does all kinds of things for your applications. And here in Visual Studio, there's this integration which includes a PowerShell-based console. And at this console, I can do things like installing a package. And I'm going to have it look online in its list of packages for the RESTful routing library. It's not only going to bring down the package and install it if it's not already present on the machine, it is also going to run initialization code for the package in Visual Studio that's going to do things like adding references and in fact making changes to our project. This routes.cs file, for example, did not exist before. Now it does. So I'm going to close the Package Manager console as we don't need it anymore. And here in this file that it added is some code commented out that looks a lot like what we were looking at in the slide deck. And if you go to the RESTful Routing Library website, there's a nice long one-page documentation, sort of beginner's guide and quick ref on it that's very informative. And it's got some code that looks like this. But since it's commented out, all that it's doing right now is automatically initializing and setting up this debug route, and that's it. Now, since we want to use these RESTful routes, and rather than maintaining our routes in the traditional MVC way, which is set up here during project setup in the global.asax.cs file, you're familiar with this most likely. But we don't want to maintain our routes in multiple places, so I'm just going to go ahead and delete this stuff. Don't need that. Maybe we don't even need areas, but we're not going to go into that. One other thing the NuGet package for RESTful routing does is add this application controller. We don't actually need it. It's a means of, they generate some code that basically implements the default behavior for this respond to feature of the framework, which, like everything else, emulates a feature of Rails. The NuGet package generates this class as a base class for you if you want to use it to centralize your processing of the respond to function, which briefly is a means of responding to requests that require different representations with different representations and doing it cleanly, declaratively. We'll actually be looking at it towards the end of the demo. So we don't care about this, but we are interested in making a controller. And we're going to add one. We're going to call it the home controller because it's going to be our home page. It's not uncommon for a RESTful web service to offer up traditional web content as well as the kinds of JSON or XML representations that are convenient for processing in JavaScript. So here I'm going to establish a view that a Razor view, an HTML page that's going to serve as the sort of demo page for the service. And for this view call to succeed, we need to add an actual view that it will produce. I'll go ahead and just give that the default name, index, along with all the other defaults. So just as a sanity check at this point, I am going to go ahead and hit F5 to debug the application. I have a view. I'd like to see it. So it builds, and oh no, a 404. How could that have happened? Oh, well, yes, of course, we could have predicted this because we don't have any routes yet. It's all commented out. So just to get our routes to our home page going here, I'm going to add a simple old MVC style route using the routing code here in the routes.cs file that the RESTful routing library added. And not much to it. Basically, we are just relating the base URL for the domain to the home controller and having it invoke its index action method. There. Oh, we don't have this class because we need to use the package. There it is. That should do it. And now let's see what happens when we go. Ah, there we are, our empty index page. So now I'm going to build the first API-style service interface controller for my interface here. And I'm going to call it users controller because in my personal finance repository in that domain I have users at the top. Users own accounts and accounts own transactions. Very simple model. And when my clients do a get on the user's route, on the user's base URL, I want them to hit this index action method, and it's going to give them back a JSON representation of the list of users. First, I will need to refer to my little personal finance repository package, just because it's got a long namespace, and so I want to qualify all the names. And here in the action method, I'm going to return a JSON kind of action object, which will generate JSON rather than HTML. And this is built in MVC. And I'm going to give it the result of the all query for users, returning all the users, which actually returns, as we see here by looking at the source, it returns an IEnumerable interface. What the JSON function does with this is basically turn it into a JavaScript array. Sometimes, depending on what kind of frameworks you might be using on the client side, you'll want to return a wrapper object instead that's got the stuff that you're interested in as a member inside it. But for the moment, we're going to be satisfied with our array here. We have to pass a second parameter to the I believe it's this, allow get to the JSON function, because there happens to be this vulnerability in browsers, a weird issue involving arrays and cross-domain attacks that basically makes JSON an unsafe format for a get. In this case, we're communicating with our own service, so we're going to live with the risk and queue the JSON function into the fact that we are going to go ahead and allow a get. It otherwise will produce an error because of this security risk. Now that we have an endpoint, controller action that we want to invoke, we need a route to get at it. And now we can start building our RESTful routes. And what we're saying here is that, hold on, let me just get a few more keys in. What we're saying here is that we have a set of resources. There are base resources, they're the outermost ones, and they're called users. And users will be the base URL because the library will take that out of this type name. And speaking of users, let's declare that you can only perform an index operation on users. So we can get a list of them. That'll reach the index action that we just wrote. And of course, we can't forget the client side of the picture. Here, since we're not so big into the client side for the presentation purposes, I'm just going to go ahead and paste this in, and obviously it would be a bit much for you to wait through for me to type. And all we are doing here is encompassed in one call, one AJAX call. It's a get. It's against the partial URL users. In other words, it's going to be domain, whatever it is, /users. It's going to expect JSON as a response. And if successful, it will run this function passing the JSON object that was rehydrated from the response body and the HTTP. And the function is going to build up the HTML for a table to put into the body of the document. This is all using jQuery, the jQuery AJAX stuff, of course, and the jQuery DOM and array manipulation as well. And this table is going to have a name column, an email address column. These are properties of users. And for each user in the data array, we're going to add a row in the table. Notice, of course, since it's JSON, everything's JavaScript objects. Name and email were properties of the C# object when it got converted to JSON back in the controller, and so it has these name and email properties as it arrives here on the client. So let's run this and see what we get. Look at that. And what all happened here, I'm interested to know. Let's refresh it and see what we get. The first few gets here, of course, are just getting the resources, static resources of the page. Here is our RESTful call that happened because of the $.ajax back in the JavaScript code. And as you can see, it's the debug web server that we're getting as our domain, and then /users. And looking inside, we see that the response is all this JSON stuff. It's the whole set of views. In fact, we can have a special nice JSON view here in the Firebug debugger, and we can see that we got an array with a couple of items. We got our Joe public user. We have our Jane lunch pail user. And in fact, as we'll see, these are rich objects. They have, each user has some accounts. The accounts have information about themselves. They have transactions. So lots going on there. And also we can see that in the response headers, we should have gotten a content type, and there it is, applications JSON, just like we asked for. And we indeed asked for it right down here, except application/JSON, text/JavaScript. This is as a result of that script code in which we are asking for this data type. And so that seems to have worked out. Now, going back to the drawing board, let's establish a hierarchy of resources. And we're going to do that by adding another controller. This is going to be the accounts controller, another empty controller. And here is what I will do in the implementation of index, which is indeed what I'm interested in implementing. Oh, we need our personal finance repository, of course, here. Our top-level users collection in the repository happens to have a get by ID function that gives us a user object, and each user object has a set of accounts. And again, we need this, sorry for the mistyping, we need this allow get for the framework to allow this get to go through. What's this user ID all about? Well, as you may remember, since this is a subsidiary resource, the framework is going to pass this value in from the URL right there. And again, the name is important. This user here is found as a parameter to this index action only because in the routes declaration, as I'm about to do, we're going to declare a resources for accounts controller in here, and so accounts is under users, and therefore to get at an account you need a user ID. So let's go ahead and add that route, and we're going to do that by again declaring a set of resources. Like the users, for the moment, we're only interested in supporting the index query. And again, as far as the client side goes, I'm going to go ahead and just copy some code. This time, I'm just making a kludgy assumption. I'm going to say, let's go ahead and just look at user number 1, which I believe is our Joe public user, get his accounts and take a look at them. Same thing all throughout. We're just building a table out of them using the properties on the JSON objects that come back. I'm simplifying, getting around floating point problems by just doing my balance in pennies, so I have to do this work to display it gracefully, and that's about all that's different. So let's try it out. Here we go. Joe Public's account name, and now there's his accounts. And again, there's the accounts RESTful call, users/1/accounts. That happened because, of course, the URL is different here. This is the URL we asked for. And here's that JSON response with the accounts in it. You remember all this stuff. So now let's delve a little bit into some of the additional features of the uniform interface that we can implement here. I am going to go ahead and copy some code now, since it's bigger, to the user's controller, stopping debugging first, of course. Now I've added 2 new action methods to the user's controller. We have a show method and an update method. The show method is to service gets for a specific user resource. So of course we need an ID for that user resource. The update method, action rather, is invoked by the put method against again a particular user resource. So again we need the ID. I actually see I made a mistake here, not maintaining my conventions, but it shows that these sort of convention-based implicit name requirements do not include case sensitivity. And in any case, the put is actually putting a new representation, a new value or set of values, if you will, as the representation of this user. And we actually have some options as to the form we take these parameters in. We could instead have taken something like this, wherein user is a domain object. This is coming out of the personal finance repository, which in this case is acting as a domain even though it's called a repository. And we're expecting the framework to reconstruct this object to set its public properties based on the properties in the JSON object that comes up in the request, so that its name property has the name from the client request, and etc., etc. And the framework will support this. Again, because of the conventions, it knows that the singular of users is user. Actually, it's this name, the name of the parameter that's looking at. If it's called user, then it assumes that it's supposed to be an object representing the client-side object that was uploaded in the request. But in this case, since the information is so simple, I've chosen to just take it as individual named parameters, the properties of the user representation to be put. And going into the implementations here, show is just using that get by ID function that we saw earlier to get an individual user object based on its ID. We were doing that in the accounts controller, as you'll recall. And it's, again, just returning it as a JSON object, very straightforward. The update method is more intriguing because an update can fail, and it can fail for multiple reasons, which are perfectly reasonable use cases, like the user entering an email address that's a duplicate of an already existing user account. So what we're doing in this function is we're constructing a user domain object using the properties passed to us in the as parameters. And by the way, I illustrated that incorrectly. Really, it would be like this. Just taking the user, because of course the ID is also a property that belongs inside the user, and the framework would figure that out. So anyway, we have a corresponding update function in our repository based as a static of the user's top level object, or class actually. This call will overwrite the contents of the user as stored in the repository with these properties. Or more specifically, it will actually look for the user with this ID and then overwrite the remainder of the properties with the values provided in the input object. And one of several things can happen. We could be successful. We might try to update a user that doesn't exist. In other words, the ID doesn't exist in the database. We might try to write in an email address that is invalid, and our backend wants to protect its database and won't allow invalid email addresses. Or there could be a clash. You could we could have as a constraint in our domain that names and email addresses are unique, and if you try to use somebody else's, then that's a not allowed scenario. So in a success scenario, again, we're just getting the user. We're re-getting him in this case, him or her, because for one thing, you get in the habit of doing so when you're writing both updates and creates, because in the create case you don't have the ID and you want to pass back the ID. So after you have created the domain object, you need to get it in its new form with the key attached so that you can return it back to your client. But also there might be other properties on this thing that we are not in the update sense concerned about, but the response nevertheless should be complete because the client's always expecting certain characteristics of a user. In the no such user case, if we're trying to update a resource that doesn't exist, well, that's a 404. And this is how you return a new 404 action result, that is. For the email invalid case, well, that's an invalid arg, and so we're going to return a 400. And this is kind of the briefest way of expressing that. And in the somewhat more interesting case, as I said, of a name clash or an email clash, we return a 409. As you may remember, that means conflict, meaning we can't do it because of some conflict among resources. So now I'm going to save this. I'm going to go over to my routes and make these routes available. This is going to be a show and an update for, excuse me, users. And we're also going to get some of that client-side source code and paste it in again. This time there's rather more of it, because we have some more interesting things to do with what's coming back from the server side. So let's paste it in and take a quick look. Now my page is going to start off with just a combo box on it. So I'm actually going to let you select which user you are looking at, whose user information you are viewing. And I'm going to use that current user ID that I get from the combo box to form URLs for my RESTful calls. There's a refresh user combo function that does a simple AJAX call. It's doing a get of the users. Remember, that's ending up in the index controller, index action on the user's controller, getting back JSON, and we're calling the fill combo with users function on success, and it's taking an array of users, and it's, instead of generating a table, it's generating the contents of the combo box. And again, it's just using the name property on the user to put in the combo items. And when we have selected a user, what happens is we launch another get against the URL for the particular user. Remember, this is going to be something along the lines of users/1, and we're going to be getting back JSON, of course, and we're going to call this onUserUpdated function with that JSON, and it in turn is going to call make user fields from user. And what this is going to do is going to make a form, basically, not a real form, HTML form, but we're just going to make a table with some labels and inputs in it. And that form is going to allow us to edit the user. It's going to have stuff for user name and email in there, and it's going to have an update button with update user call as its click behavior. If we look at update user down here, we are assembling our new user to put to the user representation on the server right here by getting stuff out of the edit fields in the table that I just showed you. And we're making a put transaction again to the user URL. And we're just passing that user object as our data, which means it's going to end up in the body of the request. And this time we're interested both in success and failure. You may remember that it fails in ways that are interesting, and so we're going to intercept those failures and do things about them. In the success case, the simpler case, really, we just make the user fields from user again. In other words, we reassemble the form. So now getting back to the failure case, here's the function that gets called on failure. And it takes a few parameters, but we're only interested in the first one, which is actually the XML HTTP request object that is used to perform the transaction, and it happens to have interesting error information attached to it in this case. I have set up a cell in that table up there to contain the error messages, if any. And what we're doing is looking at the status code, the HTTP response status code on the XHR object. And we're looking for 400s, bad request. And we put in an error message for that. And for the conflict result code, and we put in a message for that. So let's try it out. There's our combo box. As you can see, we have done a get of users so far to get that combo box. And let's choose Joe Public. Okay, here is the show. This is an index. This is a show. In other words, this is a get against a set of resources. This is a get against a particular resource in that set. And there's the JSON for just that user. And let's see what happens when we try to update. We change Joe Public to Joe Publics. Fine, it's updated. In fact, since the debug server stays around, we can actually launch again, and you'll see that, yeah, it's still Joe Publics. It's Joe Publics in the combo because we haven't unloaded the fake repository from memory yet, so the objects are still there. And I'll do that again just to demonstrate the put call. Down here, there's the put, aka update, and its request, the put, in other words, here, the body. Here we actually have, in this case, it's not a JSON representation in the upload because that wouldn't be as useful. This is more what the whole CGI layer is expecting, which is your form encoded request contents, which is pretty much the same as URL encoding. In other words, we just have name value pairs where all of the character set has been canonicalized just the same or almost the same as you would if you were putting these as arguments, parameters on the URL. And this is just exactly what gets sent up by an HTML form in a post, and it's the simplest and most common thing for the backend to support. So trying out some failure cases, what if we leave off the top level domain on the email address? Well, there we got an error, and looking at the actual transaction, there's our put, just like the last time, except this time we got a 400 bad request back. If instead we try this, we copy Jane Lunchpail's email address and try to use it, the error now is the other one, the 409, as you can see from here. So now I'm going to switch gears, and instead of adding new code to this project, I'm just going to switch over to a pre-baked one in the oven, and it is simply called demo. And here's the project. And before we delve into it, let's just run it and see what happens. So here we are again. I'm going to look at all the transactions, and starting off with the combo box as in the last time, but now we have this little table of information, this being the accounts belonging to Joe Public. Each one has a name, a balance, and, intriguingly, a delete action that we can execute. And notice also that the names of the accounts here are hyperlinks. Let's see what happens when we follow them. Here's a brand new page that illustrates or shows you and offers you operations on an account. And we have another of my makeshift forms here in a table. In this case, this is a form not for editing, modifying the existing state of something, but rather adding something new. This is adding a new transaction to the account. And down here we have the usual informative table of transactions, in this case belonging to the account, with their to, from, and their amount, and notes about them. Notice down here that we, the way we got this account information was through a get of a particular account. This would of course have been a show at the back end, a show action. But notice that what we're getting back here is the HTML. This is the page. This is not JSON. And indeed, what we were asking for was HTML, because this was the get that was invoked by that hyperlink. This other get down here that gets a set of transactions, that was used by this page to fill in its table. And of course, this is the set of transaction resources belonging to account number 1, belonging to user number 1. If we decide to put in a new transaction, let's try it. Oh, let's say they're buying a product for $99. And it's to improve my app. What happens? First of all, we refresh the table. That's another get transactions down here. But what we did in between, in response to hitting the button, was a post transaction. And this is not a web form, so it didn't happen because this is a submit button in a form. This was done in JavaScript code, again with the $.ajax feature from jQuery. And as you can see, our post had, again, form encoded values in it. And what we got back was a JSON representation of the new transaction object. So going back to the previous page, I'm interested to see what happens with those delete links. So let's go ahead and delete Joe's savings, see what he thinks about that. We were successful, and now they're not in the list anymore. Well, a few things happened. Towards the end, of course, we refreshed our accounts so that we could put the new contents in the table. More importantly, though, we have this delete, and the delete is deleting account number 2 belonging to user number 1. And our response was actually also a JSON object, a very trivial one. Sometimes frameworks expect this. This I just did for the heck of it. There's no actual software depending on it in this case. And you'll notice there's request headers and everything, but there's no actual request body. We don't need a body to declare everything that needs to be declared. It's all in the method and the URL. So let's go take a look at the server-side code that's doing all this. Let's see how that post happens. I believe that that is a create, yes, on the transactions controller, which we now have one of. And the create is taking, actually in this case, an object representation of the transaction from the domain, as I was illustrating and discussing in the earlier phase of the demo. It's also taking this parametric information from further up the URL. Remember, a transaction belongs to an account, which belongs to a user, and we need all of that information to get down to the transaction that we want to create in the database. And indeed, we use that information to get an account, and we add a transaction to that account. This function in my repository library provides as an out parameter just the ID of the transaction that got created, so you can subsequently then use it to re-get the newly added transaction object corresponding to that ID, and again we're returning that. Now looking at the delete, that's in the accounts controller. It's got a destroy method, and the delete actually can fail. For example, if there's no such account, then you're going to get back a 404, and I haven't actually accommodated that in a client-side code, but one gets the idea. And here we're using the dynamic features of C# and of the .NET framework to create inline an object with the particular properties that we want the client end to get. And this is a perfectly straightforward way, not all that dissimilar from the syntax on the client side for producing object literals. In this case, preparing an object for the JSON action result factory to make its JSON object out, JSON text, I should say, out of. And of course, in the routes, we have a little bit more accommodation for some further action. We have three levels of hierarchy. The client-side code obviously has gotten a bit more complicated. And in fact, there are two new views now. Remember, there were two pages. Well, there is an index page for users. That's the home page. Actually, excuse me, this isn't the index page for users. This is just the home page. Remember, we created it first. But there is also this show view for accounts. And indeed, in the accounts controller, we have this show method, and it is using some specialized code, or another feature actually of the RESTful routing library, to decide what kind of representation to give back. Because you see, this function is responding to a get for an account. And as you could see, when we went into the client side and navigated to those pages for user accounts, we've decided to make a part of our interface responding with HTML pages representing some of our resources. So in other words, you can view this resource as HTML as a page, or you can view it as JSON. And of course, it's an account object is an important domain object. You want this to be available through a typical JSON API call type of approach, just as we're employing for other objects in the domain model. But for this object, we also decide that we want a view. We want HTML as well. It's the same transaction, it's the same method, but we are requesting different representations. If we looked at the headers in those transactions, which maybe we did, you would see the accepts for JSON versus accepts for HTML. And this respond to call, this is another feature of the library emulating a Ruby on Rails feature. And in this case, the feature is given a request for a particular format on the part of the user, decide what kind of response to provide. If they ask for HTML, or indeed anything else that we don't specify here, they get HTML. And it's a view, it's regular ASP.NET MVC Razor view. We're passing in this case, a model object from our own app rather than the repository's domain objects. That's because we can easily integrate with all of the Razor model integration features in the framework, and so it's easy for us to just create one of these on this side and then use it in the Razor code in the view. And if we asked for JSON specifically from the client, then we're just going to take that account object and return it as JSON text. And like other features of the library, it's a Fluent interface. It's a DSL based on lambdas. Now, last but not least, I'm going to show you a tricky little twist. You may remember that in the slide deck I talked about a big limitation in the RESTful routing library and the Rails conventions generally, which is the inability to have nice human readable URLs. You can't have users /Joe Public in this case. You have to provide a numerical representation of their key in the database, or at least a number that you will use to find that user. Well, here's the at least somewhat uncomfortable kludge that is necessary to get around that situation. If you specify, and this is how, this is of course the show for the user. In other words, this is what will happen when we do a get of a particular user, which in the typical case is going to be something like a users /number representing the ID, and indeed we accommodate that case in our parameters, but we have a little twist here. This is of course now an optional parameter, an optional ID value, optional int value for the ID, and the RESTful routing library is aware of this, and if it doesn't find something that it thinks of as an ID on the URL, it will still route to the action method as long as the action method doesn't actually require an ID. And we're going to take advantage of this here to use some additional code to analyze the URL in much the same way that the RESTful routing library is analyzing the URL to find the information necessary to get the resource that the user wants. In this case, I'm employing a class that I've created here specifically for this purpose. It's basically an operational abstraction that takes your HTTP context as well as the optional user ID value. And in the case where the numerical ID actually has been passed in, we just do the old thing. We go to our repository and get the user by numerical ID value. But if not, what we do here is we get our absolute path of the URL that led to us. We do a regex match looking for whatever lies between the slash after users and the next slash. So we're going to capture that in a group, and if we succeed, what we're going to do with what we matched, which is over here, the first group, the value in the first group, we are going to search the users to find one whose cleaned up name is the same as the cleaned up representation of what was in the URL. What does cleaning mean? Well, in this case it's very simplistic. It's just going to take strings out and make it lowercase. So in other words, we're case independent up here because our cleaning algorithm takes case out of the picture, and we also aren't allowed to have spaces. So if we find this person, then we return them. And back at the user's controller, if we didn't find somebody, it's a 404. If we did, again, it's just coming back as JSON. So I don't actually have any directly browser-based user accessible features in the client-side code that demonstrate this, but I can just type what I need into the address bar to illustrate it. And so what I want here is, first of all, to demonstrate what happens when I do this kind of a get, the domain /users/1. This is just like the low-level code is. It's asking for HTML rather than JSON, but you may remember that the get is returning JSON and nothing but JSON. So what happens here is, since the browser doesn't know what to do with JSON, it can't display it as a web page, it asks you what to do with it. And so we are going to ask the browser to save the response for us, and we're going to actually, I've saved it before, so it's going to show up with the duplicates in here. We're going to take a look at it in the editor. Here's our Notepad++ again. We'll just drag that on in there. What does it look like? Oh, it's the JSON for the user ID 1, Joe Public, etc. And now I'm going to do something different. I'm going to ask instead for Joe Public right there in the URL. What happens? I get the same kind of response. In fact, let's save it. Go back to our downloads window. There it is. It names it after whatever the last name, the name that it identifies out of the URL. The browser does, just taking the last clause out of the path. And again, looking at it in the file system, and oops, did I kill my editor? Maybe I did. Here it is again. Here, I'll close the other one just to make it clear. There's Joe Public, and there's the same information. So it can be done. It's not really designed as an integration feature of the library, but if you have to do it, it, by the way, is done here in a way that is generalizable. This is the user's controller, but of course, if we were to form URLs like users/joepublic/accounts, we need other controllers to be able to do the same thing. And indeed, I've made this change. For example, the index method on the accounts does this same trick, with the user ID, makes it optional, and then uses the same abstraction to draw it out of the URL if necessary, and then gets the accounts off the resulting object. So this project, including all of the client-side code, which we haven't really gone through, is available on GitHub at the URL that I described. And let's return to the presentation. Well, that was fun, and to wrap things up, I'd like to insert a few plugs here as if I haven't taken enough of your time. One of them is the RESTful Web Services book that I mentioned earlier. Excellent book, definitely worth picking up and reading if you're going to be implementing any substantial real-world RESTful Web Services, as it's got a lot more to say on a lot of important topics than I was even able to cover in all the time I've taken here. Also, Zinx Health. You know, at Zinx, we are an agile software development shop. We're doing, as I mentioned at the outset, some pretty cutting edge healthcare IT software as a service kind of work. And through measured results, we see that we are actually saving lives in the process, which is kind of a nice situation to get into for a programmer. Not every day you can do that. And also the organization places a very high priority on your professional development, which if you've been in the business for a while, you probably know is kind of a rarity. And we definitely need more people who are really good at what they do and willing to learn and continuously innovate, both in the software and in themselves. And who knows, if you're lucky, I could stultify you in person. Also plugging a couple of things of my own. First of all, the actual source code from the demo for this talk is available on my GitHub repositories at this location. That's a big URL. Sorry about that. And also, as I mentioned, I got a blog where I talk about some of these kinds of subjects as well as other software development topics and fun stuff. So please visit compulsoryblog.com if you got the time. And also, I definitely want to give a special shout out for DevExpress for sponsoring all of this kind of thing and letting me speak to you today. Thanks so much to them, and please, folks, buy their stuff. Thank you very much. You've been incredibly patient and kind to show interest all the way through to the end. I applaud your stamina. And I thank you and hope that I will have another opportunity to say some useful stuff in the future.